Okay. So we should have a major new release of SMAC 2.0 very soonish, which makes every easier to use. It's not really about performance or efficiency in that release. It's all about improving APIs, user interfaces, and so on. Today we have the chance actually to try that out. So we have an alpha release of that new version. And I hope that will make it for you much easier now to dive into SMAC and use it. What you should do is really going to GitHub already. We have different kind of orgas. So of course, for our research projects, we have always the AutoML orga. For educational purposes, we have AutoML-edu. So go there, and then there is the repository SMAC _for school 22. Going there, it's a very simple repository. There's not much in there other than a README, which has not much content. And there's a SMAC IPython notebook. And there's also a link, actually, the same IPython notebook on Colab. So if you would like to run it in Colab, that would be the perfect chance to do that. If you click on it, you should actually directly go to Colab. You can then, of course, copy that IPython notebook into your own Google Drive and then run it with your own modifications. If I have not set it up correctly, you should not be able to modify mine right now, but really have to copy your, that for yourself first. I hope I will present that sufficiently well, because as I said, René was preparing everything and he's a much better expert than I am. So there is a small trick at the very beginning. What you have to do is installing Python 3.8. That's a requirement for the new release of SMAC. And unfortunately, it's not directly supported by Google Colab. I think it's running 3.7 if I'm not wrong. So we have to install a mini anaconda and so on. So if you're pressing that button, that runs then for a few minutes actually, then there's a trick that really Google Colab will use that then. What you have to do is refreshing that website. We have to really refresh that. I really don't understand why that is working. But it's not giving you a new instance in the cloud, but it's somehow sharing some environment variables afterwards. René came up with that trick. So don't ask me how. So the first one is really all about installing simply Python 3.8. So you can simply do that, and then, as I said, it's also written up there. You should reload your browser, so refreshing the website once. Then the next panel is actually, I might have a bit of slack, is on installing SMAC itself. And as you can see here is that we're using really directly an installation from the SMAC repository of the new development 2.0. It's really an alpha release here. There might be smaller changes, and we hope that we really have the full release within the next 2 or 3 weeks. Good. So far, everyone's on board? You can still simply try to run that. It takes a minute. In the meantime, let me explain a bit why we have here a bit different view of what you already learned so far in the last days. If you're thinking about back to the tutorial by Matze, Kata, and Eddie about Auto-Learn, or about the Auto-Cluon tutorial by Nick. Here was always the idea, really, you have your data, you put it into your AutoML framework, and somehow some magic happens at the end, you're getting well-performing model. In different kind of ways, be it like combination with some kind of BO and pipeline optimization, or be it like doing some kind of stacking and so on, right? Different kind of ways doing that. And SMAC is more like one level below that, actually. It's not meant as a full AutoML tool, but it's really meant as a very efficient optimizer you can then use in any kind of flexible way you would like to use it, right? So remember what Luigi told you this morning about Bayesian optimization. SMAC implements Bayesian optimization. It also implements, for example, PIBO, the user price you can use with SMAC. It implements different kind of multi-fidelity strategies, so you can also be very efficient actually in optimizing and so on. right? It's really an efficient optimizer, and now you can start to use it, for example, for HBO. You can start to use it for configuration spaces like in AutoScaler, so really for full pipelines. You can start to use it to configure your deep learning. So for example, in AutoPyTorch, we're also using SMAC these days. You can use it for anything you want. You can use it for reinforcement learning. You can use it for compile optimization in principle. So whatever you would like to optimize, whatever kind of space you have, whatever kind of cost function you would like to minimize. So by now, for me, I was now saying we have installed Python 3.8. So it's also giving you now again the message, please read out the browser. Oops, okay. I hope now I have not messed it up.
It's working. Could you get the link again?
So if you go to GitHub AutoML -edu smack_4school22, and then if you are there, then go down and there's direct the button to the Google Colab. Okay. Let's see whether I have to redo that because I accidentally did something here. No, that is now already working. Nice, so that's working for me. So it's really ensuring that there's Python 3.8 actually, installing SMAC afterwards. Takes also a minute or two actually with all the dependencies. But while it's doing that, we can already look into the very first mini example. It's a really heavy delay. So the idea here is, let's say we would like to configure a very simple model, and let's say that model is a support vector classifier, so support like a machine, has some kind of configuration space. So what we're passing in is the only thing we're doing here is optimizing the hyperparameter, which is called C, regularization strengths more or less of the SVM, right? So only one hyperparameter we have to optimize. So we're only using here in the end scikit-learn as the underlying package for the SVM. What we're doing then is saying, okay, we would like to have cross-validation as a validation score. What we're doing, since we would like to minimize, it's 1 minus that mean validation score over all the data we have here. So in the end, that's simply defining the function we'd like to optimize. And as I said, it would be simply cross-validation. Okay, so that's more as we have to implement first, or have to think about first what would like to optimize for, right? Now how to use SMAC on that. What you need to do is having a configuration space object. So you have to define the space you would like to search in. The space, as I said, has only one single hyperparameter, which is called C. And what we're simply doing is having an upper and a lower bound. So the lower bound is with 0.1 and the upper bound is 1000. Somehow magic happened by ninja knowledge, as we learned today, right? How to set these upper and lower bounds, no one can tell you. That you have to look up maybe in other papers or in documentations, or have to play around with that. But that's always a bit of expert knowledge you need. Then what we need also is to tell SMAC actually what it should do, and that's what we call as a scenario. The scenario object, first of all, needs, of course, the space. It has to search in later on. We also simply assume here that we have a deterministic function. So calling that more than once, we will always return the same result given the same configuration. That's, of course, rarely true in machine learning. The most stuff these days are randomized. And what we're also saying, yeah, let's say it's really cheap function. We can afford 200 function relations. Of course, you can also here reduce that number. You can also try it with 10 or 20 or whatnot, right? So here really going full in and 200 different C values. And then what we then also tell SMAC what kind of presetting it should use. So we have seen Maybe if I dig deeper into AutoCluon, there's also presettings. We're using very similar idea here with Mac, and we call it a facade. The facade here we're using is for HBO, since we're doing an HBO problem, right? And then the only thing we have to do is calling smack.optimize, and then we'll start to optimize. Good. Hope that's running.
One question.
Yes.
Development of branch seem to exist. Should we just use the normal development branch?
No, it has to be the 2.0, otherwise the example will not work. But for me it was existing, so I'm surprised. Okay.
Can we use the V200 alpha 1 tag?
You can also try that. So yesterday it was working, and René promised me he will not change anything. Let me try to write a message. But I would also guess that you can simply then try to use the tag actually we have on that alpha release. Maybe if you tried that out, maybe it's on pip by on PyPI by now.
Yeah, the pip one, pip equals Mac.
Yes, okay, then let's do that here. Maybe it was yesterday not online, maybe it's now online. Should be exactly the same actually. Good. Okay, yeah, René also told me we should use the pip command. Good. Good. Coming back to our mini example. Everything on board still? Other questions? Good. Now what you should now be able to see is what SMAC is actually doing. It's a bit verbose actually. So what we see is that we have an initial design of 10 configurations. So it's more as doing 10 random samples first. As we already see from Luigi's talk, we try to explore a bit the area, right? Then what we always saying that we have an incumbent. An incumbent is really the best one we have seen so far. So the updated cost of incumbent here, my one was 0.04. Please note we minimize, not as Carola is doing it all the time, maximizing, we're minimizing here. And then it starts really to do Bayesian optimization on top of that. So it will try different kind of challengers. So challengers are new configurations we haven't tried so far. And at some point it figured out there's a challenger, so there's a specific value of C. So before it was 266, and now it's changed to 716, and that has a slightly better error. So it's 0.03 now. Then it's running for a moment again, and then it figured out, okay, that was maybe too high actually. So we're going from 716 down to 98, and the error improved actually goes down to 0.02. So we're doing that over and over again. At the very end, the final value for setting for C, SMAC figured actually out was actually fairly low, with 5.3. And had an estimated cost now of 0.01. So we started for less with 0.04 and then improved roughly by a factor of 4, finding something better. So that's really the most trivial example we can run SMAC with, right? It's really more as standard Bayesian optimization. This is more a catch. We don't use any kind of GP for that. We're using a random forest under the hood. Why do we do that? Random forest simply has a big advantage. It scales nicer to more dimensions without any kind of credit tricks and so on. We can also support categorical hyperparameters easily. So if we have some kind of category choosing between, I don't know, SGD or Adam as your deep learning optimizer, we can directly do that because splitting on a tree and having categories is fairly simple to do, right? So that's the reason why the HBO default for us is actually random forest. Good. Let's try to dive a bit deeper with a more complex example where we use multi-fidelity optimization. Multi-fidelity, as a reminder, was the idea of saying, okay, we don't want to train until convergence, but we'd like to stop early on and make decisions. So only training for a bit and deciding what performs well, we should continue. What performs poorly, we stop. Good, so, and we're doing that here now, optimizing very simple MLP model, actually. We need a bit more for that. And we, of course, we're using here also only very stupid MLP classifier from scikit-learn. In practice, you would then go for PyTorch, TensorFlow, or whatnot, right? But here we see a much more complex configuration space now. We say, yeah, let's try to optimize the number of layers, maybe between 1 and 5. Let's optimize how many neurons we have in each layer, between 8 and 256. Sorry. Now there's a very important trick here saying, we'd like to do that on a log scale. Log scale, give me 1 second. This is a very nice thing, because if you're doing an optimization on a log scale, it simply means if you change the number of neurons from 8 to 9, bless you, from 8 to 9, should give you much stronger signal if you're going from 255 to 256, right? So if you have many neurons anyway, and then adding one more, it's maybe not so important. But if you have very few neurons and adding one more, it might be much more important, right? So we're doing that here with a log scale transformation on that domain.
A very simple example at the beginning. What model we were optimizing?
That's the cross-validation error of iris dataset. That's a support vector machine. Yes, SVC is a support vector machine classifier. So a very traditional old model no one cares about these days, maybe. Yes, it's only C, it's only the one hyperparameter C of the S4M, so regularization strengths implicitly. So that's really simple. So it's only one hyperparameter, it's only cross-validation on the iris data. That's really trivial. And I would guess you can get very decent results also with much fewer trials than 200. Okay, I have 7 more minutes. Let's see what we can also do. So we also, as I said, can have categoricals. So for example, here the activation functions can choose between logistic, TAN-H, and ReLUs. Different kind of solvers we can use, ABFGS, SGD, Atom. We can use then, of course, also integers again, like batch sizes, but we can also floats like learning rates, and so on, right? You can now construct an arbitrary complex configuration space, actually. We can even then do some kind of conditions and restricting that, and making, for example, then dependencies between, yeah, if I'm choosing SGD, I should use maybe others differently than I would use if I have Atom and so on. So I'm going about that a bit quickly. So then we have to again define one function which more or less gets the configuration itself. So one very specific instantiation of our hyperparameters and return some kind of numeric value which we're optimizing for. And what we're simply doing here is more or less parsing again a bit the configuration, passing that then to the MLP classifier, more or less that knows what kind of MLP we would like to have now. And we're doing again cross-validation, but in that case here we have a stratified k-fold cross-validation, and we have here the digits data set in that case. So it's still a very simple example, right? And since that returns the cross-validation score always, yeah, higher is better, we again doing the same trick, 1 minus that score. Good. So that's more or less returns one floating value we would like to minimize again. We have to do the same as before. We have to define a scenario object now. We already had the config space before, right? Now what we can also tell SMAC is not how many tries it should use, but also how much time it should use, right? So we could say, yeah, either you should stop after 200 function evaluations or you should stop after 60 seconds. So we simply now define both here. Whatever happens first, it will lead to termination. What we also now have to tell, because of the multi-fidelity approach, is what is the minimal and maximal budget. And if you're going a bit back to over here, so the function itself gets now a budget object, and that tells more how long it should train. And that's more here the maximum number of iterations, so the number of epochs in that case, right? So you should simply say, okay, the minimum number of epochs should be 5 it should train. It can already terminate configurations after 5 epochs. And it should do that for at most 25. So we expect after 25 epochs, it should really train under convergence. So we won't train for longer than 25. You can also parallelize that actually. Number of workers is in that case here only 1, because we're doing that in the cloud with a single core. Good. Then simply calling SMAC, and here we're using a different kind of facade. It's now the multi-fidelity facade because, as I said, we would like to do multi-fidelity optimization. We would like to do very efficient stuff here, right? Then again, the same core saying SMAC dot optimize, and then it should already start. And what we also do here is having, again, checking what is the default actually configuration, how well it perform, and what SMAC actually figured out. What is the default? So you can define that as an expert saying, yeah, my deep neural network always has, I don't know, in that case, a very stupid default, 1 layer. It has only 10 neurons. It's always used TON-H and add them as a solver, as an optimizer. So you can already define where you would like to start with, right? What is a good starting configuration you normally would use? That helps SMAC, first of all, to start with something reasonable and not completely random. And secondly, it also helps you to compare against it, whether you really improved, right? So it's more like bringing expert knowledge into SMAC with a 1-point estimate, right? Not like the distributions from Luigi, but really only 1 configuration. You can also then look up actually for all these kind of hyperparameters defined here, how you could add then these user priors as Luigi introduced before lunch. Good, so my time is running up a bit. I'm going about that very quickly. More or less, you have again a bit of output telling you what SMAC tried out. So it's doing then internally hyperband combined with spatial optimization. So it's running hyperband, but for really sampling the configuration, it's still BO. And it's still in that case BO with the random forest. You see from time to time now SMAC finds better configurations. So for example, it was defining a batch size of 155, showing the learning rate, more layers, more neurons, and so on. Actually, we can also figure out what the final one then was here. Or what's showing is actually the incumbent only 1 in that example when I was running that. It's a fairly small network still, but okay, it's digits classification. It's not a hard deal, right? Good. Last but not least, let me only briefly mention that we also support multi-objective optimization. As we have seen already these days, saying we don't want to optimize only for accuracy or validation scores, but for something else. In that example, what we're simply doing is also measure the time of training our MLP model. So the moment we construct more our object, we start measuring time, and at the very beginning, very end, we also measure the time again and say, okay, that's the time. So what we can also return to SMAC is not only one single float, but actually dictionary. So the first one would be here 1 minus accuracy, so it's a loss score or an error, and the second thing would be time. So if you then do all the stuff on how to tell SMAC actually how to run that part, you can get at the very end also period of front. Now you have on the one axis time, so training time, how expensive was it to train that, and 1 minus accuracy as the other ones, and seeing that I think we fairly well covered actually period of front, showing okay, it can be fairly expensive in training, can get also very good scores. If you'd like to be faster actually, so investing less time at some point actually, so you have a very small model, takes less time to train, but also our error starts to increase. And then you can start to choose from the treasure font what kind of configuration you'd like to use. Okay. That was a very quick tutorial. As I said, René would do that better than I do, but I hope that gives you first insights on how to use Mac. You can play around with that. If you have further questions, you can either talk to me. If Eddie should be around these days, you can also ask Eddie. Eddie is a research engineer from Frank's group, or you can simply use the GitHub issue tracker. We will respond also to that. Okay, good. Then let me check whether the Decathlon team is already here. Decathlon team, can you hear us?
That's our view.
Hello.
Excellent.
Hi.
Hi. You can hear us?
Yes.
Yes.
Perfect. We have to share for a brief moment the setting that everyone can see you. So thank you for making it, and thank you for introducing the Decathlon now. I hope you can see everyone sitting in the room. So we have, I think, close to 50 people sitting in the room right now. And also some more students from my side actually in Hannover. They're really eager to learn now about the Decathlon, what it is all about and how to win that. So please give us all the cool hints that no one else knows. That would be very important. Nevertheless, I think we learned quite a bit already in the last 2.5 days already. So a second ago, I was introducing Mac, how to use that. They know already how to use AutoScaler. They know how to use AutoGluon. So I hope everyone is very prepared now in that room to have a decent submission then. Good. We see you. So you could also share your screen if you would like to show something, and then I would hand over to you.
Awesome. Great. Thank you
Great.
so much. So I think what we're going to do here is I'm going to be doing the first half of the presentation, and Sam is going to be doing the second half. So in the first half, I'm going to kind of like talk about AutoML for diverse tasks and kind of the motivation behind the competition. And then I think we're going to have to like awkwardly kind of switch screen sharing to Sam so that he can tell you more about the actual competition halfway through. But yeah, let's get started. Oh, it says that screen sharing is disabled.
Oh, yeah, I thought your co-host.
Making you co-host again, and then you should be able to share the screen.
Okay.
Oh, the one below.
All right, Samuel was.
Okay, now you should be able to share your screen.
Ah, awesome.
Yeah, sorry for that.
No worries. Okay. All right. Can everyone see this?
Yeah.
Cool. Great. Let me minimize this a little bit. Okay, great. Oh my gosh, so we're so excited that we were invited to like run the hackathon for the fall school. This is like honestly like such an honor, and like we've run 2 hackathons so far for the AutoML Decathlon competition. One of which was at Wisconsin, where I'm a grad student, and one of which was at CMU, where Sam is a grad student. And for both of those, we had to like, introduce like the, idea behind AutoML and stuff. And like for this, we had to like change our slides because it seems like everyone here is already going to know a lot about AutoML. So, so I guess what I'm going to try to convince you of before Sam talks about the competition is about this AutoML for diverse tasks problem. So yeah, let's jump right into it. Okay. So like I said, AutoML and diverse tasks. What is it? As we know from kind of machine learning history, there was this data set that people developed called ImageNet, and it took like a lot of like time, effort, and money to develop this data set. It's pretty large. There are like 14 million labeled examples in it, and it's like 1,000 classes. And it's like, you know, at the time it was essentially the largest scale like benchmark in machine learning. Over the course of like several years, people developed kind of better and better models to do well on this benchmark. And here's an example of one here. It's this is GoogleNet or GoogleNet or whatever they called it. Yeah, the reason I'm showing kind of the network architecture here is that it's very much like not clear why it was designed this way or why this should work well for image tasks. It's just very complicated, and there are a lot of layers, and there's a lot of like interconnections between these layers. And so it kind of makes sense why it took so long for like humans to develop these neural network architectures that do well on ImageNet, because it's not clear why something like this would do well. And we see from this plot on the bottom that indeed, you know, over the course of like 5 years from the beginning of this ImageNet stuff, I guess in 2010, it took about 5 years to actually like get down to actual like human error rates on this benchmark. And now we've surpassed it. But that's 5 years is a decently long time, especially in machine learning world. So the takeaway from this is that both designing the data set and designing these models, these were very like expensive and time consuming efforts. You know, there was a lot of like human design, and both of these things, like they had to design like new ways of like getting humans to like label the data easily, and like being able to like automatically label new points and stuff like that. And then like, you know, of course, Google like spent a lot of time designing things like GoogleNet. Roughly the idea behind AutoML for diverse tasks is, look, like not every problem is ImageNet. We have a huge number of emerging machine learning tasks, like in the natural sciences and economics, and you know, all of these other disciplines that people would like to apply machine learning to. But most of these people don't really know too much about machine learning in the first place. And so what we'd like to do is we'd like to, like in the overly optimistic ideal case, you know, automate things on the ImageNet scale for problems where people don't have ImageNet scale experience. And so we want to kind of develop very, very strong AutoML techniques that work on emerging tasks. So before we dive into this too much further, let's just get back to the basics here. What are just the core things that people need for machine learning? Well, we need 3 things. We need models, we need data, and we need hardware to run these things on data. Well, we're going to ignore the third one because, well, to me, I think hardware is less interesting, but also you can just rent it from AWS. So that's, in my mind, a more or less solved problem. It's not, but we're going to treat it as such. As for models, of course, as I alluded to, choosing models requires ML expertise. I mean, we saw what happened with ImageNet. It took 5 years to develop complicated, crazy looking like deep neural network architectures that ended up beating human performance. And as for data, creating these large labeled data sets is expensive because you have to pay people to label the data. and it's also time consuming, and you have to somehow scrape images if you're doing something like ImageNet. And so this can be a costly venture for sure. Again, as I alluded to with the emerging tasks stuff, for non-machine learning people, doing both of these things is pretty difficult. I know that, like, you know, if you come from a machine learning background, you probably do this like all the time. You like construct models and you like load data sets, or you go and like construct synthetic data sets, or this and that and so on. But most people don't do this. Like, doing machine learning is a very like specialized thing. And so as for constructing models, like how do you do this without, you know, a team full of like machine learning PhDs working at Google? Or for data, like, you know, oftentimes you just don't really have enough of it, but you want to use some kind of like automated software for your problem, for whatever reason. Tons of reasons crop up in the sciences, for instance. And the answer that I'm sure you're already convinced of as fall school attendees is that the answer to these things is automation. And in particular, for the first one, you know, a common answer is like, oh, just, you know, run some, you know, hyperparameter tuning or neural architecture search routine, and this should give you a decent model. And then as for like data, there are actually like tons of ways to deal with this problem. You know, in nowadays, people, you know, do transfer learning using like a foundation model, for instance, or they do fine tuning. Another solution that I like for this is this thing called weak supervision, which is a way to construct data sets automatically. Yeah, so we would like to automate both of these things. So now that I've kind of talked a bit about kind of the background and motivation for AutoML for diverse tasks, let's kind of talk more about that. So as you know, AutoML automates the ML pipeline. You're at the AutoML Fall School, so I'm sure you know that. And the core idea behind this, of course, is that it should reduce the need for ML expertise. Okay. So kind of the extension of this is that in the like ideal case, it would make ML accessible to non-ML experts, right? As I alluded to earlier, who might be working in like the sciences or economics or like other disciplines. But this kind of like raises a question of like whether many like current AutoML solutions actually like work in practice for like these kinds of diverse domains where people are kind of perhaps the most likely to use these methods. Because, you know, you can imagine like someone in a lab somewhere working on some like, I don't know, like genetics application or something, and they have a data set and they know like roughly like, okay, like I can turn this into a like prediction problem because I've taken like a statistics course or something and I know that much, but I don't know anything about neural networks. I don't know anything about like, you know, which models to use. So I'm just going to search like automated ML. Oh, look, I found this thing on GitHub and I'm going to run it. And essentially, it appears as though things like that, situations like that don't always pan out as we would like. So the question is like, who actually benefits from AutoML? And the reality of it, it appears to be that a lot of the beneficiaries are people in like machine learning communities that have already like had kind of a lot of attention and a lot of like hand design in terms of their like ML pipelines. And so in reality, you know, things like domains like computer vision, you know, I mentioned ImageNet, natural language processing, so things like language modeling and things like this, and basically domains that are already like totally dominated by machine learning. These are the domains that AutoML tends to shine in, it appears, which, if you believe the motivation that I gave about AutoML for diverse tasks, it should kind of follow that this kind of defeats the purpose almost. And the expectation here is that any field using machine learning should strongly benefit from automated machine learning, even more so than fields within machine learning, ideally. So like this person in this like lab should be able to download an AutoML package and it should just work for them, or at least give them a reasonable solution that works well enough for them until someone else comes along who has like more machine learning knowledge, can design something. So yeah, the answer to this is that not exactly. Mostly machine learning people benefit. So the main takeaway that I wanted to convince you all of is that we need to make machine learning more accessible. And congratulations, you're already like helping to do that by learning about AutoML. But this is kind of the next step. We need to make AutoML more accessible in particular. Go out and design methods that work on all of these tasks, that solve all of the world's problems. That is essentially the motivation behind our competition. And we're hoping that you all can submit very cool things that indeed solve problems such as this, genetics problem that this person in the lab was working on. So with that, this is the end of my half of the slides. So I'm going to pass this off to Sam to talk about the competition. And yeah.
All right, thank you, Nick. Okay, yeah, so I'll be taking the rest of the portion of the intro session to just talk about the hackathon and aspects of the competition. And so hopefully this hackathon should be like a brief introduction to the competition as a whole, and like Nick mentioned, AutoML for diverse tasks. So just a quick overview of our schedule. So after the session, we'll leave some time for any questions you might have and let you form teams. So we recommend you guys work in teams, preferably up to like 5. And then the rest of today and then the early chunk of tomorrow will let you develop your methods, and we'll be available on a Zoom call or over email to answer any further questions you may have. And then finally, for our closing session tomorrow, after you guys reconvene after lunch, we'll do some participant presentations and award some prizes based on those. So for the team presentations, these are entirely voluntary. So you can you can sign up to present on either things you tried during the hackathon, so specific methods that you tried to implement, or things that you didn't necessarily try to implement, but you decided to research and thought were interesting. There will also be an incentive, so a raffle for submitting to the official competition. So $350 Amazon gift cards for that. And we are saying that your method has to outperform our existing baselines in order to be eligible. And of course, for the official competition itself, the results of which will be announced in November, there is a $15,000 grand prize. Okay, so as for the logistics behind what I just talked about, so for the presentations, we'd like for you to provide a description of some of the things you tried and what worked, what didn't work, what you found to be interesting or successful. Ideally, you keep them about 5 minutes each, and we'll judge them. We'll judge them based on a combination of your attention to the goal of AutoML for diverse tasks, the creativity, and the overall presentation quality. And we'll release a Google form to sign up for these presentations. Yeah, and then again for the raffle, as long as you submit an official competition submission on the Code Lab that surpasses the existing baselines, you'll be eligible for the $50 Amazon gift cards. Okay, so now I'll talk more about like the actual elements of the hackathon and what you'll need to be working on. So we'll provide you with a pre-made Jupyter notebook. So it's entirely self-contained. So there's cells that are set up that will create the environment for you. So it'll download the data, it'll download the necessary code, and we recommend that you run it in a tool such as Google Colab Pro, and we'll provide reimbursements to cover the cost of your subscriptions. So this notebook, it'll walk you through the major points of the competition pipeline. So ingestion, which is like data loading, training your model, and scoring, which is of course generating predictions, and then calculating the individual task scores. Yeah. So the main file that you'll need to edit for this hackathon is called model.py, and there'll be instructions detailing the format of that file and the changes you'll need to make. And overall, the notebook will just provide a local testing environment for your methods and implementations. So what you'll be working on is a subset of our competition's development tasks. So in the official AutoML Decathlon, we have 10 diverse tasks varying in domain and their input and output characteristics and like the task type. So tasks in vision, so image tasks, some time series tasks, even some physics tasks, and varying input dimensions and different output types. So it have classifications and regressions. So for the hackathon, we'll be taking a reduced subset of those 10. So it should still be representative of the task diversity, but it's less costly to work with. So you can actually like do some meaningful work in this time frame without being bogged down by long run times. So more details about the competition pipeline that are provided in your hackathon notebook. So for the ingestion step, the data sets will be read in a standardized format. So you'll have your batch size and then 4 other dimensions indicating time, channel, and then height and width. So these are passed to the model and used to train it, of course, and generate predictions. And then following that is the scoring phase. So individual scores will be calculated for each task based on some predefined metrics. And these are all standardized such that a lower score is better. And then after that, all the individual task scores are aggregated into a final metric, but this will not be included for the hackathon. So for this hackathon, you should worry about the individual task scores only. If you're interested, you can read more about our metric, our aggregate metric on the competition sites. So what you'll need to implement is a model class within a model.py file, and there are 3 mandatory functions. So the initialization, the training, and the test. So training is where most of your work should go. So this is where you have a lot of freedom to decide things like, all right, how do I want to use the characteristics of the task to determine things like training schedules, hyperparameter tuning, architecture search. And you can add any other necessary files you want to the overall directory. So we'll allow you to use other modules, other packages, and pre-trained model weights, existing implementations, as long as they're open source. So as a general design philosophy for your method, so you should treat every task as if you're basically completely blind to its domain. And the information that you do receive is limited to, again, so the dimensions of the data, the shape, whether you're doing like a classification or a regression task, and then the final evaluation metric. So all of these characteristics will be passed into the model initialization as metadata. So you can directly look at this information and use it to decide how you want to train your method. And then again, yeah, so what you should decide in your method are like the architectures you want to use, how you want to search, and the search space, and then hyperparameters and tuning, any training and validation strategies, your objective functions, and whatever else you may need. So we've compiled a starting list of ideas you could explore. So within hyperparameter optimization and traditional AutoML, there's a couple of methods and packages for you to look at as well, and in neural architecture search. And since our competition is sort of inspired by a previous AutoDL competition, we also recommend that you take a look at the previous winning submissions to that. So within hyperparameter optimization, AutoGluon is specifically motivated by diverse tasks. And within neural architecture search, Dash is also specifically motivated by diverse tasks. Unfortunately, we should let you know that from a previous hackathon just a couple of days ago, it did come to our attention that AutoGluon has some problems interfacing with our official competition pipeline. So it'll still work for your hackathon. It'll still work for the hackathon if you want to experiment with it, but we apologize in advance that we haven't resolved the issue with AutoGluon in our official competition pipeline submissions yet. So this portion is for if you're specifically interested in submitting to the competition. So it's perfectly fine if you're wanting to focus on the hackathon subset here, but in case you're interested in submitting to the competition, this is how you would do it. So there will be a directory containing 3 basic files. So there's a metadata file that you should not change. It's not much. It's just necessary for the competition Codalab. There's a tasks to run YAML file, which specifies a subset of the tasks to be evaluated on. And then, of course, the model.py file, which is where all the work should be going. And of course, as I mentioned before, in this directory, you can include other packages and pre-trained weights. And you'll want to zip all these up and submit that to the competition. So our Codalab site is this, and we'll be sharing these slides as well, so you can access all these links. So you want to go to the Participate tab and submit or view results. And then you'll see a screen that looks like this, and there's a very large Submit button. You want to click on that and upload your zip file. And then below that, there's a table that contains all of your past submissions. And what you can do is you can collapse or expand individual rows. And within those, there's a lot of information that you can go back to help you debug. So you can either download your entire submission zip file, or you can download individual log files. So you can look at the ingestion step. So that would be loading the data and then your model.py's training. You can also look at the prediction step. So this is where your predictions on the test sets are being generated. And then the specific scores and the logs for each of your tasks. All right. If there's any questions, we'll be happy to answer them.
And any questions? If there are any, maybe come up to the wall.
that you're using a microphone like here, that would be best maybe.
This works best.
Better than what we did last days.
Hello, awesome stuff. So just a quick question on the 7 data sets. Oh, sorry. Just a quick question on the 7 data sets that are going to be part of the hackathon. What modalities are covered?
Oh, so we have, I believe, an image data set, an audio data set. No, the audio one's been left out. There's a music, like next note prediction for music. There's data that's been sourced from a tabular data set, but we vectorized that for you. So, and then, sorry, Nick, do you also want to chime in on this? Let me see if I can pull this up as well.
Yeah. Okay. I see where you're coming from. I think like people, like all of the hackathons so far have like asked the same question. And I guess like, yeah, like we could, one way to answer this is we could tell you like what, data sets are involved. And for the hackathon itself, that's, I think, probably going to serve you well. But note that if you want to submit to the competition, we do encourage you to essentially make methods that work like assuming you don't know anything about what the modalities actually are. Because so we give you like 10 tasks that are like these totally random, like diverse modalities. And then after the competition ends, we're actually going to change the data sets, and we're going to like run all of the methods on 10 new tasks.
May I ask a quick question? What you mean by we wouldn't know the modalities?
Yeah, so
like generally speaking, the AutoML system would probably be able, you would probably at the minimum tell the AutoML system that something is an image, for example, potentially.
Right. I mean, we assume essentially that you have like, well, we're giving you like metadata about the tasks, but we're not like saying like, oh, okay, this is like face classification, or this is like, a specific like partial differential equation or something. Like it's, we're giving you like the shapes of the data. And so you could feasibly like infer like from the shapes, like, okay, this has 3 channels, this has height and width. This is probably an image task. But you should essentially like include logic in your method that like automatically detects these types of things.
Okay, gotcha. And then you said that for tabular tasks, you vectorize it. Why? Or I'm just kind of wondering, like, yeah, what is the form of the tabular?
So it's essentially just a set of feature vectors, like one-dimensional feature vectors. And mostly we did that for convenience.
Okay, gotcha. Thanks.
Perfect. There were also questions from Hannover. Stefan?
Yes. Hello, can you hear us?
Yes.
So if I remember correctly, on for the competition, I think I've read something about like you can be a co-author of a paper or something like that if you win the competition. Am I correct with that assumption? I think I've read something about that.
I'm not entirely sure. So I think yeah, to be honest, I'm not entirely sure how the NeurIPS thing works, or how like we are going to end up like, I think we have to end up like writing a retrospective about the competition. So I mean, at a minimum, you know, if you win this competition, like we're going to be talking about your method quite a bit in like our retrospective. And if you develop a new like type of method that like, you know, wins the competition, that's probably like a fair like place to start with like writing your own paper. But I don't, to be honest, I don't really know like what the like paper writing landscape is like, period, with respect to this competition.
Okay.
I guess
So just for perspective, for many competitions this is the case, but for this one, let's see. I guess the organizers need to think about that.
Yeah.
Okay. And another question: am I correct with the understanding that the competition is already running since July? So.
Mhm.
Okay, so we have to compete with people that might have already worked on it for like 2 months if we would actually submit something to the competition in the end.
Well, if it makes you feel any better, there have only been 3 submissions that have beaten all of our baselines so far. And one of which like barely beats our baselines. So there's still like a lot of room for improvement.
Okay. Well, I'm quite relieved to hear that.
Yeah.
Yeah, that was all.
I think you're very well prepared after attending now the AutoML 4 school, having a lot of knowledge which maybe other attendees of the competition don't have. So I would not be worrying too much. I'm fully optimistic. And also, if someone is winning really that competition, writing then a paper about a solution should be also fairly easy. I would not worry too much about that. So Hannover, you can count on me. If you're winning that, we write a paper about that. I promise you.
Yes, I can promise that for Freiburg too. But I have one more question. So can you talk a little bit about the baselines that you already have in there that would probably make a lot of sense for the attendees of the fall school to bootstrap from?
Yeah. So if I am remembering the leaderboard correctly, our top baseline right now is just XGBoost. And one idea for improving this is essentially like combining it with if-else logic with other methods. So I think one other baseline that we've like released code for is, for example, like if you have kind of, you know, a tabular looking data set where you just have like a feature vector, like something that's time series or something, use XGBoost. If you have data with like spatial dimensions where it's 2D or 3D, use wide ResNet, for example. And yeah, in your code, you can include like logic like this that uses the task metadata. And we can tell you for sure that this works. I don't remember if these combo methods are on the leaderboard or not, but internally we've like run these and they work very well. So if you want to know how to win the competition, that's probably how to do it.
And XGBoost, how do you run that for big tensors?
Yeah, so we just flatten the data.
Okay. All right. All right, lots of room for improvements. More questions?
Maybe one more proposal. We have a Slack channel for the fall school here. So there's anyway the workspace for AutoML. And there's a special Slack channel for fall school 22. If you could join there and then provide help if needed, that would be best simply. Because we will then also scatter in different rooms soonish. So not everyone then can simply join the Zoom call also. So would that be possible that you go into that Slack channel?
Sure, sounds good. We can share like all the resources through there as well.
Perfect. And you know the AutoML Slack workspace, right? If not, I should send you a link.
I think Amit knows the AutoML Slack space. I think he's posted there. But
I don't believe he's available right now.
It's auto-ml Slack.
Oh,
but
yeah.
We can send you.
I think I'm in it, so I can add Sam.
Okay, great.
Perfect.
And in there, it's a channel Fall School 22.
Got it.
It's a notebook, I think, for the start of it.
Yeah, also you talked about the notebook. The link to that would just be in the starter kit on the website.
Oh, so we had it in our slides. We're planning to share the slides, but we'll send that to the Slack channel immediately.
All right, good. And then there's all the links.
Nick,
and
since you're already in it, do you mind just copy pasting those right now?
Sure. Yeah.
Or just a link to those slides in general.
The people are not connected to Zoom.
Yes. 1 second.
Yeah, but
Perfect. Anything else you would like to know? Last moment. Everything clear?
What should people expect in terms of compute resources that you have for the test tasks? So is it a ballpark? Is it like an hour, 20 hours?
Are you referring to the actual competition test tasks?
Yes.
Okay. Yeah.
Is that reflective of the training task, or you're just not saying and you might run it for a minute? Or
yeah, I think it's going to be reflective of the training tasks. Yeah.
Okay. And do you roughly have like in mind, this is a big task, so we give more time, or is there diversity in, well, this is a big task, but we're going to give really little time to see if they can do fine tuning, stuff like that?
I see. No, we've roughly like scaled the amount of time that we give, that we allocate for methods, like based on like the amount of time that it takes for us to run our baselines on each method. So we're not like compressing the time at all.
Okay. Good. Final questions before asking questions in the Slack? Not the case. Then.
So what we prepared are now several different rooms that we don't have to sit all in here, and then it will be very loud, and the Wi-Fi is maybe not sufficient. But I guess Rea or who else can then show you different kind of rooms. So we have smaller rooms, actually, I think 2, 3
we have 4 rooms.
4 rooms even. Awesome. Roughly so 1 group per room, I would guess. You can sit in there, work together. We would recommend roughly team size of 5.
5 was recommended. Sounds good. For the folks taking this as a lab course, I said yesterday maybe make 2 teams of 3. You can also split up. It's sort of up to you, and maybe that gives us greater diversity if you want to continue on this afterwards. It's up to you. We're not going to micromanage it. It's sort of independent of the lab course, and do whatever you want to do in order to be most effective. Yeah, so teams of 5.
Is anyone still in need of finding a team? Okay, then maybe you should come then after that session to the front, and then we can figure out that you also have team members, right? Everyone else, I believe that you have a team. Where will show you around simply where the rooms are, and then it's up to you to win the competition. I'm really looking forward to that. We meet again then tomorrow after the lunch break, right? It was on the slides when we're meeting again.
Yeah, so by the way, really cool that you're doing this with the final presentations. So just to recap, you would like every team to do a presentation of 5 minutes if they want to be eligible for this prize, right?
That's correct, yeah.
Okay, and in that presentation, it'll be judged based on novelty or performance or a combination thereof.
Yeah,
Just so people know what to do.
Yeah, kind of a combination of those things. So novelty and things that you've tried, comprehensiveness, or like another option is, if you end up like not like running methods in particular, you could also just present on like the problem of AutoML for diverse tasks. So we're kind of leaving this like kind of wide open. So as long as you submit a quality presentation, then that'll probably be rewarded. So
submit a quality presentation, it's given live, right?
Yeah, sorry, I misspoke.
We don't plan on putting emphasis on performance for the presentations, so yeah, don't need to stress about like your metric scores.
Yeah.
Mm-hmm. All right, that's good to hear.
Okay, so one final hint from my side. Having a lot of competitions done with Frank, submitting our submissions. Submit early, submit often, submit as often as you can, actually, right? The worst thing we did sometimes was really like, yeah, we're working for weeks and weeks, and then maybe a few days before the final deadline, we started to submit and figured out, okay, we have somehow of a problem with the APIs and so on, something is not running, and then figuring out what the problem is fairly hard to achieve after you did a lot of changes to your code base, right? So really early on, start to submit, figuring out that really everything is running, and then go to implementing your complex ideas.
I do fully agree. However, for this hackathon, are people actually submitting to the server already, or should that be afterwards, or should that be in a focus now?
But for the raffle, it was saying that they have to beat the baseline, right?
For the raffle, but that's for the actual.
That was for the actual deadline. I thought that's also.
No, the raffle is $50 for the, like 3 times $50. The winner is $15,000, which is a slightly wide gap. I guess we also had this proposal of second and third prizes or something like that, but that's completely separate for this hackathon. You don't need to submit to the server. If you want to get familiar with the system, if you want to actually compete later on, then it could also be a good idea to try that already if you then have any questions about the system. But Sam and Nick are on this Slack now, so they hopefully won't leave this tomorrow. But still be available for questions for the actual thing. So maybe this doesn't have to be the focus, and you can actually focus on getting something done on these 7 data sets that are not as expensive. Is that in your interest, Simon? Or should people try to submit already?
No, submitting is more of like an extra like additional thing. And if you're able to, then great, by all means do that. But I think the purpose of the hackathon should be to focus on the subset and get familiarized like with the idea of the competition.
All right, great. Then thank you very much, and we'll be in touch via Slack and see you tomorrow. Thanks Nick. Thanks, Sam.
See ya.
All right, let's get on it.